the Advancing Energy Podcast, featuring topics and trends on precision power conversion, measurement, and control solutions.
Welcome to the Advancing Energy Podcast. I'm Johanna Knudsen. I manage content marketing strategy for our industrial power conversion and critical sensing and control product groups. We're here on location in our Fort Collins, Colorado facility to talk to Alex Schul about our fiber optic temperature measurement technologies. Hi, Alex.
Hi, Johanna.
Can you tell us a little bit about yourself?
Sure. I'm Alex. I'm the product management specialist for the FOT product line here at AE, part of the critical sensing and controls group. I've been with the company for a couple years, about 3 or 4 now, and I used to work in the plasma power group with the Evers products as well.
Great. Can you give us a basic overview of what is FOT technology?
Yeah. So fiber optic thermometry is a way to measure temperature using fiber optics and phosphors. And phosphors are materials that emit light when they're exposed to some other kind of radiation. So in our case, we use an LED to excite the phosphor and it starts to emit a light. And then the light decays, and the decay rate of that light is dependent upon the temperature. So we can measure the decay rate and then back calculate the temperature from that, which is what we do with our converters. FOT specifically stands for fluoro-optic thermometry, which is AE's way of doing this with the phosphors that we've developed and our converters too.
Great, that's fascinating. So why would someone choose this particular technology for their application?
Yeah, that's a good question. So FOT can be used anywhere to measure temperature. It's better when it's used with EMI or electromagnetic interference. EMI causes more traditional methods like thermocouples to be less accurate and the temperature reading won't be quite right. So that's where fiber optic thermometry comes in. Some good applications are with microwave heating in the semiconductor space, medical MRI machines, and power transformers. Another good benefit is that our products don't drift over time and they're really reliable. We've designed them at the very fundamental level for that reliability, and so they'll last decades if they're treated right.
Okay, great. So Alex, who tends to buy these products for their applications?
Yeah, so we have a lot of products that are off the shelf that anyone can purchase. A lot of people will use it for lab work, especially kind of in the semiconductor or medical spaces as well. OEMs or original equipment manufacturers tend to buy these products in higher volumes too, and will do customizations if they need to. And these OEMs are typically in the semiconductor industry, medical, or power, like I mentioned before.
Okay. How are these products actually used in the field?
Yeah, that's a good question. I conveniently brought a little show and tell. This is our M1100, and usually these are pre-installed in the equipment, but they'll pre-install the converter, and if you're using it in the lab or R&D, you don't need to install it anywhere. You can just have it on the desk just like this. And we have a lot of different probes. Some of these are custom or just off-the-shelf ones that are good for general use. And usually, depending on the probe, it'll just connect straight to the measurement surface like that. And that's it. You'll hook it up to your computer and it'll start reading off the temperature and recording that data for you.
Okay, cool. So Alex, what I really want to know is, what do you find cool about this technology? What really excites you about working with it?
I think it's cool that we can use just very fundamental physics to measure in a very broad temperature range. -200 all the way down to the cryo range, and even up to 450, which we're starting to push that temperature limit as well. But it's just very basic physics, and we're able to do a lot with that.
Thanks for joining us, Alex. And be sure, everyone, to like and subscribe, and stay tuned for more.
Thank you for joining us for this episode of the Advancing Energy Podcast. Be sure to subscribe.